Slightly adjust it now. Let me adjust the screen. Smaller. Okay. Reasonably okay. On this but down I can come. Voice clear? No, voice is clear. Little fast you have to give comments. If voice clear, there is a little lag actually here. Voice clearly audible? Yes, okay. 1 minute. I will go to that question. I have taken a photo of that one. It was asking you, camera, okay, it's in the camera. Okay, just once. Okay, I will write the question first. Already we finished SFD, BMD is ready, that point located. I start here. See, space there. If not visible, let me know immediately. See, the beam is like this. See, it's a last chance today for you to understand all the basic concepts. See, 25 meter span, correct? 25. First is 8, 10 and 7. 8, 10 and 7. Reasonably okay. See, here UDL, okay, looks very odd actually. It should come same size. And actually no problem. Okay, UDL. Here UVL of this way UVL, see, this type, intensity is not visible, 48 kN per meter, and here trapezoidal load of 40 to 28. So here 40 intensity, here 28. Purpose is what? I want different intensities. See, this is 40 kilonewton per meter. This ordinate is 28. Space is not there. Manage it. Kilonewton per meter. See, point A, point B, C and D. That's all. C and D. This reaction VA is 306.08. 306.08 kilonewton. This reaction VB is 329.92. See, today's class I am going to wind up this. All the behavior means what? The pattern of the curve. I will explain it more. See, sufficient. This is 8 meter, 10 meter, and other one is 7 meter. Now, first draw shear force diagram. Already drawn last time. So, I will just draw once in front of you. Calculations are shown yesterday. See, this is shearing force diagram. See, all values are in kilonewton. Left up, right down, positive. This is thoroughly explained. This all I will not tell now onwards. If you look left side, here also look left side. If you look right side, here also look right side. Class after class I was shouting, like take bus ticket, go to bus stand. If you book the railway ticket, go to railway station. Do not book bus ticket and go to railway station. Both are embarrassing. So, wherever you want shear force, if you are deciding to look left side, I already told you, shearing force or bending moment or axial force or torsion, all four are section forces. What do you have to do? You have to look only one side. Repeatedly I told earlier, equilibrium complete, entire beam. And also one more, Equilibrium direction based, like up, down, right, left, clockwise, anti-clockwise. One hand you can explain. Section force, not one hand, two hands required. Compression, tension, axial force, shear, or bending moment, or twisting moment. These are told endless number of times. Anybody is new, go to the course SFD BMD in YouTube, learn systematically, understand, then continue here. Not simply comes halfway in between and tell this is not clear, that is not clear. Okay, now I will draw shear force diagram. Okay, now anything is left. Okay, values I will get once again, no problem. Values I will get once again, 306.08, 329.92 sufficient. I will leave this one and go to once again chat box now. Actually I left and went to camera. Okay. Okay, now see. Just to understand once again, remember, today is the last class for variation. And today at the end of the class, I will give you too many examples. Suppose I will tell you, if this here one point load is there and if point load is there, what change will come, that also I will explain today. So that once for all, or I may give more and more example here afterwards. So make a note of everything. After today, you should never ask, sir, why curve goes this way, why curve goes that way. I will tell that way. I want to go left side, I will take left turn. I want to take right side, suppose I am going in a road. I want to take left turn. I will put left indicator. Then I will take left turn only, not like so many people. They will put left indicator, take right turn. That is special drivers. So someone will ask you, why left turn? I want to go that road. Why means I already told earlier. See, for everything there is a limit. See, now take your mobile is not there, I kept it there. Take your calculator. Start. This is the last chance for you to draw SFT and also BMD systematically. See, start. I told you SF calculation yesterday I have done. That is actually for those who are writing examinations. Because there, if you directly draw SFT, marks will not come. Except academic field. If it is a practical oriented knowledge, who wants to show the calculation? So take your calculator, start. I told always start from left side. You can start from right side. If you start from right side, again you can go with the load. If the load is going up, you can go up. If load is coming down, you can come down. But you have to change the convention. You have to tell left down, right up, positive. Or if you want same sign convention, if you start from right side, you have to go against the load. Load going up, you come down. Load coming down, you go up. So many people they tell SFT falls under a point load, SFT jumps under an upward load. For BMD, if a clockwise couple is there, SFT jumps, anti-clockwise, SFT drops. All bogus. For BMD, if a clockwise couple is there, if you start from left side, right side, yes, correct. Yes, BMD will jump. BMD will not jump. BM ordinate will jump. BMD will remain there only. What BMD jumps? So BMD will not jump. If you jump, you can't tell earth is jumping. You are jumping. But if you start from right to left side ordinate, then if a clockwise is there, BM ordinate will drop. So that is actually very crude way. And people tell that one as very authoritatively. BMD jumps, BMD falls. What jump and falls? First of all, I will tell BMD will remain there only. BMD will not jump. Okay, start. Now, I told you, start from left side. You just go with the load. If the load is going up, you go up. If load is coming down, you come down. Point load means suddenly there. If it is UDL, linearly go down. If UDL is there and UVL is there, go down, not linear, parabolic variation, second degree. See, if it is UDL, there is no confusion. Why? Linear. Linear. Suppose I want to join this one to this one. Linear. Join. You don't have to decide slope, nothing. But if parabola is there, see, for example, someone will tell join here to here by parabola. I have got so many options. See, one option keeps on dropping. Second option goes up and then comes down. One more option comes down and goes up. So you cannot tell that way. So therefore, when curvature comes for either SFD or BMD, you have to see the slope. Last I will tell, remember, dV by dx. See, V is shear force. W is intensity of load. Intensity of load. Intensity of load is valid only for UDL and UVL, not for point load. Point load, sudden change. But actually, even for point load, class number 100, I have given lot of principles there. Then, rate of D, when you write dV by dx, you should know one thing. Rate of change of shear force is intensity of load. Some people tell minus W. No, I proved it wrong. If you go for minus W, it is wrong. It is correct if you start from left to right. If you consider from right side, then it will become plus W. This I proved earlier. Therefore, our important is not plus minus sign. W, intensity of load. And also, dm by dx, rate of change of bending moment is shear force. Now, that is intensity of load, that is shear force. Now, remember, once for all, you tell rate of change. Actually, rate of change is what? Tell me, if anybody can tell. For a diagram, be SFD or BMD, rate of change, differentiation is actually what? At least tell me one answer. Rate of change is actually what? Rate of change. Oh, Mr. Sridharamurthy joined, no problem. Hope you can audible for you. Thank you. He didn't ask me to send the trial one. First of all, tell me, rate of change means what? As per mathematics, you tell dy by dx, differentiation of y with respect to x. Okay, rate of change of y. But what is rate of change? When curvature comes, rate of change means what? Tell me answer. Slope, that's all. Slope, because slope is not theta, it is tan theta. Okay, therefore, this is nothing but slope, this is nothing but slope. Therefore, remember, at any point, this is applicable anywhere, at any point. See, slope of SFD, slope of the SFD is always equal to intensity of load. Intensity of load. Load intensity more means slope is more. Load intensity less means slope is lesser. Suppose either side you see there. If either side same intensity, same slope. If slope either side intensity different, then where intensity is lesser, slope lesser. Where intensity more, slope more. Therefore, remember, for SFD, when you want to decide the type of curve, this way, that way, this way, whatever way you want, all you remember is, see the for SFD to decide the type of curve, see intensity of load. Later, same way, see intensity of load. So I will tell you lastly, why I should write. I am telling by words. Make a note. If you want to decide how is the curvature curve for SFD, you see intensity of load. Intensity of load more means slope is more. Intensity keeps on increasing means slope keeps on increasing. Intensity keeps on decreasing means slope keeps on decreasing. Intensity is 0 means slope is 0. Slope is 0. Remember, same way for BMD, that dm by dx is shear force. So slope. When you want BMD, when you got BMD problem, to decide the curve, type of curve, what you do? See what? What you have to see? For BMD, to decide type of curve, what you have to see? Tell me. What you have to see? To decide the curve, type of curve for BMD, what you have to see? What you have to see? Slope, correct. Slope means what? For BMD, slope. First. Further I will not ask. Slope of SFD. What is this one? Slope of SFD is intensity of load. Full gone. Slope of SFD is intensity of load. Slope of BMD is slope of SFD. How it is possible? Slope of BMD, rate of change of shear force is load intensity. Rate of change of bending moment is shear force, not SFD. Slope of SFD. Okay, that's all. Or you can remember, if shear force keeps on decreasing, slope will keep on decreasing. If shear force keeps on increasing, slope also will keep on increasing. So remember now, last time I will tell, for shearing force diagram, when the slope, when you want to draw the correct type of curve, slope will tell you. See, slope will tell you, I will tell you how it comes. The slope will give correct idea. So, if you want to decide the type of curve for SFD, see load intensity, shear force, load intensity. Bending moment, see shear force. How intensity of load varies, that way slope of SFD will vary. How shear force varies, that way BM will vary. Full clear now? For shearing force, you have to see intensity of load. For bending moment, you have to see shear force. Full clear? I told you earlier so many times. Full clear now? Tell me, full clear means no problem. In case time is not sufficient, if by chance today I will take more time, tomorrow on class is there. I will give plenty of principles for you without any problem. I will draw so many diagrams here, so that those who attend and understand correctly in future, wherever they go, they should tell how to draw, how is the type of curve. You show me this, how to draw, what is the shape, how is the type of the curve. You should tell, no problem. You give any question, I can draw or I can decide. Okay, now start. Go up by how much? See, as much as possible. Here, this much space is there. One more thing, maintaining scale is very important. As seen, see, cantilever beam, as seen so many people, what they do is, their space stops here. BMD they want. See, they get BM here, 0. Here BM, 20 came, they will mark 20. They will find BM here. 100 came, they will mark 100. Here BM, 300 came, they will mark 300. Anybody will agree? 20, 100, 300. Will anybody will agree? If you do this way, what will happen is, your slope will not come correctly. It will look very ugly SFD BMD. Of course, value will be same. It looks very ugly. Ugly things should not happen from those people should not do it if they learn from me. Therefore, start. Now, see here, 306.08. Here 329 is there. I will put now only sufficient space. I should see BMD space required for me. I should see the screen also. One minute. Okay. If I come up to here, 306. Okay, little more okay. Now, 1 minute now. I just see the screen once. So that I should see sufficient space for BMD there. 1 minute. Where I can't see anything. What is this one? What? Nothing visible here? Oh, what? Oh, yes, okay. Because it was paused there. Now it's okay. Okay, done. Voice, there is no problem. Now see, available space is much more in YouTube. Compared to Zoom, I have this much freedom I don't have. Now see, I can come up to here. I should go live. 1 minute. Almost up to here I can come. The chat is... 1 minute. How to switch off? Oh, okay. Yes. Oh, almost up to end I can go. Okay, no problem. Start now. Now I will draw SFD. I explained already in the last class. And for this batch, that is what? BSK batch, this has been told many times. Therefore, others, if anybody joined, get the benefit. You should study all the classes in YouTube course, SFD, BMD, and then you study this one. No one should tell. What he told is not clear. See, now, 306.08 right here. 306.08. Then, from here to here, UDL is there. So, gradually come down. How much you have come down? Oh, this intensity. I forgot. I forgot the intensity. Let me see. What is the intensity there? Oh, it is not here. It is in the photo. Anybody can tell me? Otherwise, I had once again go to the WhatsApp and see the photo there. Anybody can tell the intensity there? Forgotten. Now what to do? Or I can still calculate these two loads and this reaction, total reaction. I should subtract, I get it. But if you tell it, useful for me. If you can tell the intensity, useful for me. 16. I think it is not 16, I think. See, are you sure it is 16? Are you sure it is 16? Are you sure it is 16? Okay, 16. It is 16 kilonewton per meter. I saw somewhere someone commenting laptop problem. Some setting problem because everybody is getting it. Maybe some setting problem. That is the only chance. Maybe you are not able to put comment, I think. Some setting problem will be there. Otherwise, not possible. Okay. Okay, after class you will see. Okay, yes, okay. Now, from here to here, come down by 16 into 8. You calculate. 16 into 8 is 128. So, from here, when you come down by 128, see, 128 total load. See, from here to here, come down by total load. How much it is? 306.08 minus 128 will give you 178.08. See, one more thing. 306, half is 150. Somewhere here. Why? That also equally important. Not randomly. 128 point, how much? 178. Okay. 178.08 is the value here. It is a linear variation. So, no confusion. Come this way, over. Now, from here to here, come down by total this load. How to calculate? See, your calculator is already showing 178.08 minus this total load. How much total load? Minus, you get this bracket. Total load equal to 40 plus 28 divided by 2 into 10. That is 28 plus 40, half is how much? 28. 48. I think 340, I think it is. It is 340 kilonewton. So, if you come down by that much, this ordinate here, when you reach here, will be 161.92. 178 here, 161. Reasonably okay. 161.92. Correct yesterday? 161.92. Yesterday correct? Tell me. 161.92. In laptop, vertical and small screen. In mobile, okay. Then watch in mobile only. Full screen. Let me see. Some settings are required, I think. I will inquire that one. I will inquire about it. Is that correct? Last time answer. 161.92. Correct? Okay. So, and now, 161.92. Let me check once again. Minus 24 into 7 is. Okay, correct. Now see. This is uniformly varying load. Therefore, from here to here, it is parabolic variation. Oh yes, the moment it is parabolic variation, you should be careful. How? See, I will draw curve. One chance, curve comes this way. One chance, see there. Or another chance. Curve comes this way. Tell me, which is correct? First one or second one? The first one which I considered was correct or second was correct, just now drawn. Which is correct? The first one or second one? Which is correct? The first one I considered, then I removed it, and second one. First one I wrote this way. Second one I wrote this way. Tell which is correct? First one or second one? Which one correct? Second one correct, because see here, if it is this way, see here, what will happen? If you draw this way here, curve, here to here, As you go this way, what will happen? See, intensity keeps on decreasing. When intensity keeps on decreasing, slope should also keep on decreasing. But see here, the slope keeps on increasing. See, it is becoming almost vertical here. No. If I draw this way, see here slope is there. As you go this way, see now, the slope keeps on decreasing. So this is correct. And now, see, for this line, slope is 16. Why? From here to here, anywhere you see, slope is 16. For starting of this parabola, slope should be 40. Means it should be more than 16. See, if I draw a tangent here, this I told yesterday, I am not writing once again. The slope should be 40. So, see this line, slope is 16, it should be steep. Why? From 16, it should become steep now. 40. Now, as you come this way, slope keeps on reduces. Finally, when you reach here, remember now, when you reach here, slope is not 0. Suppose, imagine, this is uniformly varying load like this. See, 1 minute, see now. Suppose this is uniformly varying load of this type, then, see, when you come here, slope should be 0 here. Why? 0 intensity. But no, instead of 40, when you reach here, slope should reduce to 28. See now, this slope is 40. If I draw tangent here, this slope is how much? 28. Therefore, still slope is there here. Still slope is there. How much slope? 28. Okay, now. So therefore, it will cross the baseline here. That also I explained last time. And that point, I will take a new point. A, B, C, D, say E. E. I will take X from here. This already over last class. See, somewhere here, a point E is there. Okay, now, X. I have seen some genius people to get X. 178.08 divided by X equal to 161.92. 161.92 divided by 10 minus X. If Mr. Ramanujam is there, maths expert, he will feel ashamed. He will tell, for a similar triangle, when variation is linear, this genius is using that for curvature. That is high level of mathematics, not possible for me. I cannot go to that level. It is too high for me. Using similar triangle property, when curvature is there, is utter nonsense. Don't do it. See, you can see here, this way. Okay, now, one more thing. Suppose it is 40 to 38. It will be almost like a straight line. Even then, technically it is wrong, but X will come very near to correct. In structural engineering, especially mechanics or SOM or structural analysis, you never make such mistakes. In RCC, okay, people will tell, almost okay, take linear variation because both are almost same intensity. So many approximations we make in RCC and steel. See, like shear stress, rectangle section, it comes this way. RCC, it comes this way. What IS code told, take this way. Tau V equal to VU by VD. In the RCC class, I told the reason for that one. Okay, now, such approximation, even when you got stress diagram in RCC, see, this way. For this parabola, people use area 2/3 base into height, CG 3858. It is wrong. That is only for a parabola of equation y equal to 4h by L square into Lx minus x square. Not for this parabola. But error is too small. IS code only told, okay, use it. It may involve 1 or 2% error. Such RCC still okay. But not in structural mechanics or elements, mechanics or SOM, strength of materials or structural analysis. You should give value to mathematics. Okay, now. From here to here, again shear force reduces. Here, how much? 161. When you reach here, come down by half into 7 into 48, 100%, it is 329.92. Okay, now, if it is a UDL, straight line, but if it is a uniformly varying load, see now, here to here, once again parabola, and important, from here to here, when you want to go, two options for you. See, one of the options, see, and see, one of the option, first option this way. This is wrong because, see, as you go this way, what happens now? intensity of load decreases. But here, as you go that way, slope increases. It should not be steep, flat. So it should come this way. And here, when you reach here, see, intensity is 0, it should be 0 slope. And here, maximum slope. How much slope here? For this second degree parabola, for this side, slope is 28. For that second degree parabola, that side, slope is 48. So therefore, see, how is the tangent here? It will become more steep here. This, yesterday, I already explained. So, sufficient. Actually, in your course, earlier, this all I told. If requirement is there, tomorrow, because by next I have to go for couples and overhanging beams and cantilevers. So what I will do is, maybe one class we will use it for discussing these technical points. Okay, tomorrow I will do it. Discussing technical points, which are very important. If not over today, one more class tomorrow, Friday. Tuesday onwards, seriously, we will start SFD BMD for couples, when couples are there with the loading, and then important overhanging beams and cantilevers. Okay, start now. SFD. Now, SFD drawn. Yesterday I have shown all the calculation. I explained once again. See, reason, so that I also will learn. Correct? Suppose I ask this question in the college. I explain once again because you are learning. Meanwhile, by explaining more and more, I also will learn. If it is in the beginning of the college classes, students will tell, yes sir, practice makes perfect. I will tell them, practice will make perfect. I won't agree. Concept makes you perfect. Okay, leave it. Practice will make perfect where? Procedure or easy way to solve. But perfection comes with the concept only. Okay, now, start. Everything told yesterday, draw the shear force diagram. Actually, today I am in the flight mode. Therefore, remember, I have put the flight mode today. I do not want disturbances by anybody by call. It is in flight mode. Though Wi-Fi is working, in case network problem is there, inform me immediately. I will remove the flight mode so that I can use mobile data. In case, suppose any lagging comes, in that case, inform me immediately. Or if it delayed, you can call my number also. This number you can call. I will give the number for you also. See, I told 80886-3637. This number you have to call. You can immediately call me and tell also. So that if any problem is there, because I will always go for till I am able to block the calls. I don't know procedure still. I am learning it. Procedure is there. Till that time, I will use flight mode or aeroplane mode. The moment problem is there, you can call immediately. See, because charting will take some time. You can call. I will immediately go and remove the flight mode. Then I can use mobile data. But otherwise, no disturbance now till the class is over. Okay, start. Now, further, note this number. Further. Now, some statements are there. Very important. Shear force diagram is drawn. As usual, plus minus IO. Okay. See, draw this way shear force diagram. Let me see who will complain. Let people find mistake. Let one person come and find mistake. This is wrong. What is wrong? You are wrong, I will tell. If a comment comes, they will tell lit flat. That all, it is not a graph sheet. Shape this way. They will tell, suppose I find shear force here, the point will come later. Okay, it will come this way. But it can't come this way. Okay, now, after SFD is done, make a note. Observe the, I will not write here. Why should I write? Observe the SFD, right here. Observe. Okay, observe. Then, 1 minute now, to understand A, B, not required, C, D, this is new point E. Observe the SFD. Check whether, or observe, is SFD crosses waistline somewhere? Your answer, yes. Is it a known point or unknown point? Unknown point. If it is an unknown point, locate it. So therefore, observing SFD, let E be the point between what? C and D. See, if it happens in UDL or this type of UVL, thoroughly over in class number, today is 98. maybe 95, 93, 92, 93, 94, 95, etc. over. Or in a YouTube course, so many examples are there. Okay, now, between C and D, at where? Nearest standard point, C, at X from C. X, it is your choice. X from, I will take C. One more thing, last warning for you, see. Suppose it is uniformly varying load of this type, if the point comes here, you better take X from here so that you get a triangle. You can avoid the trapezium. Or, if it is uniformly varying load of this type, suppose a point comes here, then you take X from here because, look this side, you can avoid the trapezium. But when it is trapezoidal variation, if a point comes, whether you take X from here or X from there, you cannot avoid trapezium. Therefore, here hardly matters. You can write, I can take X from either C or D, does not matter. Okay, I will take from C. Okay, now, some will tell, sir, why don't you split the UVL represented by trapezium into UDL and triangle? I will tell only cowards, Kannada, hedigalu antare. I use that same language. Cowards, darpok in Hindi, I think. People who are afraid of mathematics. You have the concept. If you have the concept, why should you bother? You tell, I know the principle of trapezium. So, I told in the YouTube class I did it. Why? It is for universal public. Therefore, I thought, so many people are there who are afraid of trapezium. They are taught right from second semester only to divide into parts. But of course, sometimes I have seen blunders are made. See, cantilever beam of this type, BMD comes this way. The change of EI is there. Now, what they will do is, they will divide this like this, and then one parabola, one rectangle, one more parabola. These two are correct. This is parabola. When they apply the formula, it is complete nonsense. Complete nonsense. In one of the class in that course, I am going to upload it under the name area of the BMD, used for moment area method, conjugate beam method, three-moment theorem, so many methods, etc. This is a wrong. They cannot do that way. It is a mathematical blunder. So many people who are doing, later they change. I will prove it there. They will tell, divide into rectangle and parabola. No, you cannot do it. It is outrightly wrong. Therefore, you do not go for such things. Trapezium is trapezium. See, over. See, X from C. Now, to locate E, what you have to do is equate shear force at E to 0. To 0. Okay. 0. Okay. 0. But what to do is, now, you can come back here. For that, you require intensity here. I can mark here only, no problem. But you can mark here only. What happens is, for clarity, I will remove this one now. What I will do is, I will show only the beam here. See, I will show only the points C and D here. I will show C down. See, this is actually in your BSK class. This is not done earlier. That's why I am giving too much importance. In the BSK class, this class is for BSK. That is a separate course, not SFD-BMD course. Entire structure engineering basics. So see, intensity is 40 kilonewton per meter. It's a bigger sketch will do. Okay. Here intensity is 28 kilonewton per meter. Joined by a straight line. Okay. Now, there is a point here. See this point that is called E. I am taking X from here. Okay. Now, the full base is how much? Full base is 10 meter. Now, I want intensity here. See, now this is the loading. I want intensity here. That is intensity W at the point E. It will be in terms of X. Now, here 40, there 28 over length of 10 at X. Sometime people will do one thing. They will put a line here. They will apply something. Don't do it. You are engineers. Linear interpolation. If that is not known, not fit to be a structure engineer. Therefore, see now, I am taking X from here. From 40, it will reduce to 28 there. How much it will be here? It is more less than 40, more than 28. I will not explain because in YouTube, there is a class called Mathematical Concept and Tricks. Class number 1, class number 2, class number 3. I stopped. Actually wanted to continue other commitments. I will continue. This class number 3 is exclusively meant for linear interpolation. I explained when it goes this way what to do, when it goes this way what to do, and also when the table comes. See, sometimes in RCC it happens, or in RCC PT tau C variation, or in 2A slab, as Ly by Lx increases, alpha x increases, alpha y decreases. I told both of them that class, nearly 2 hours class, is meant only for interpolation, and I told some financial example there also, so that people understand very easily. Money matter means people understand. Today 100 rupees, after 5 days, see, I'll tell you, today 100 rupees, okay, after 5 days, it becomes 50 rupees. Okay, in 5 days, cost reduced to 50 rupees. After 3 days, what is the cost? Sir, 30. Sir, 80 rupees. I don't know, not 80, 70 rupees. How? How means they don't know. They will mentally calculate. 70, correct. 100 minus 50 divided by 5 into 3, that much you subtract from 100, or 100 minus 50 divided by 5 into 2, that much you add to 50. If you are going this way, from this 40, subtract the drop. If you come from that side to 28, add the extra. Now I will not tell anything, thoroughly understand. And those who come to my regular classes, interpolation, know, directly write the answer. Your intensity WE will be, see, your W at E will be red color, papa, equal to, see, from here, start, 40 minus 28 divided by 10 into X. Sorry, further I will not tell. Or if you simplify, it will become 40 minus 1.2 times X. Enter here. It is 40 minus 1.2 times X is the intensity. Okay, now start. I told equate shear force at E to 0. Right. Therefore, shear force at E equal to, start here. Here shear force. See, somewhere here is the ordinate. Look this side. When you look this side, see, start. Plus 306.08, plus 306.08, plus I not written, minus 16 into 8, actually not required because that is equal to 178.08. You can start from here only. At the left hand, 178.08. Continue. Okay, do it. Minus what? Minus this much load. That much load, see here. That much load, exaggeration. That is 40 plus 40 minus 1.2x. Why? Sum of the two parallel sides divide by 2 multiply by x. Sorry, I will not explain because in the SFD BMD course, I don't know how many times I explained how to find shear force here, or how a trapezium, how to find the load. Equate to 0. Then you will get an equation that is 0.6 x square, then 40 plus 40, 80 by 2 is 40, minus 40 into x, then plus 178.08 equal to 0. That will give x equal to, now tell the answer. Yesterday I told that x value will come. Actually, so far I repeated only for your information. So it is 40 square minus 4 into 178.08 into 0.6 equal to root answer minus 40 divided by 1.2. 4. See, 2 values of x will come, but remember, your x should be more than 0 and less than 10. More than 0, less than 10 is the applicable value. Other value will go out of range, non-applicable. So that value comes to 4.79719639 9 is the answer. 1 minute now. Suppose I take x from here. That value has to come. It has to come. 5 point, actually I am taking a risk here. 5.202 803,601. If it not come, today I will make my class last. I will not teach structures anywhere in future. If it is not coming, okay, leave it now. But we will do one thing. We will round up to fourth decimal. When you take 4 decimal, this 9 will make it 0 here, 8 here. I will take x equal to 4.798 meter. No, 79, okay, sorry. 7972 meter I will take. So enter here, x. 4.7972 meter here, and immediately do one thing. That x value substitute and get w at x. You substitute. Why should I do it? In this equation, 40, you substitute. Right here, wx equal to 40. 40 minus 1.2 into 4.7972 will give you 40 minus 1.2 into 4.7972 will come to 34.24336 kilonewton per meter. I will round up to 34.2434. I will write 34.2434. Why? 4 decimal sufficient. Kilonewton per meter. Was the same answer we wrote yesterday? Tell me. Was the same answer was there yesterday also? Check first. Tell me. Was the same answer we got yesterday? Was the same intensity we concluded yesterday also? I do not want changes. Okay, I'll see the photo. If I see photo, I can make out. You are not answering. I have to see the camera. Tell me the camera. Hey, camera. Yellappa camera. Camera is camera. Yes, photo is still there. Just once. 34.24. Yes, 336. I will take 34.2434. Yes, correct. Same answer we got yesterday. Then I stopped there. Correct? Okay. Yes, okay, done. Leave it now. Now, everything is over. Okay, now this diagram I am not removing because I want to save the time. Okay, now see. All over now, I will remove. All removed. This also I am removing. Removed. Remove. Start. Now go for BM. If you want, you can do one thing. Enter here. 4.7972 meter. See now. Total is 10 meter. Midpoint is here. Slightly this side. I meant to see. If you maintain scale, beautifully diagram will come. Okay. Now go for BM calculation. BM calculation. One by one in order. Sagging positive. Very sorry. If any newcomer is there, if he asks me what is sagging, no idea. Sorry, I don't know. Start. You can save time by writing all values in kilonewton meter. Start. All standard point first. BM at A, beautifully 0. Then BM at C. Okay. Look that side. I am not explaining. Why? If I explain, you should, those who are regular, you should comment. Sir, you are time wasting. If you explain to us BM at C, look this side, you are wasting time, you should tell. Okay. Plus 306.08 into 8 minus 16 into 8 is the total load into 8 by 2. Fast, tell me the answer. Fast. Give the answer to third decimal. Fast. It will come plus. Fast, tell me the answer. You see that I don't have to lift my calculator. Answer. BM at C. How much? Today only required. BM at C. Oh, this much time. Answer fast. No answer. This much time for BMHC. Again, you are forcing me to calculate. This is called no cooperation. This much I am struggling. Oh, no, BM value. Okay, what to do? If you don't give, helpless. See, now finally came. 1936.64. Thank you. Finally. 1936.64 kilonewton meter. Now, do one thing, make a note. If you understand, make a note. Otherwise, drop it. Or BM at C, if you look this side. Okay. This you don't calculate. I will calculate in front of you. See. Actually, when you want BM at C, look left side. Why? Only UDL. Look right side. Unnecessary complication. Still do it. Plus 329.92 into 17 minus half into 7 into 48 into 10 plus 1/3 of 7. Now important, minus 40 plus 28 divided by 2 into 10 is the total load into 40 plus twice of 28 divided by 40 plus 28 in 10 by 3. Sorry, explained 1000 times. Calculate. I will calculate in front of you only. See. Yes, 1936.64. Same answer came. Yes. Okay, now BM at, next BM at D. When you want BM at D, see, when you want BM at C, look this side. When you want BM at D, look that side. Therefore, you can avoid trapezium. Therefore, if the shear force diagram crosses baseline, either here or here, the trapezium has no effect on what? Complications. Correct? You can avoid the trapezium. Why? This side you look this side, here you look this side. But now you are forced to consider BM at an interior point of trapezoidal loading. So therefore, this question is more important for learning. Start. Look this side. Plus, some people are there. Sir, it is anti-clockwise. If anybody tells in the comment, sir, when you look that side, clockwise you took positive. When you look this side, it is anti-clockwise, it is negative. I will tell, do one thing, switch off the mobile, leave the class, and drop the study of SFD BMD. That's all. It is, sometimes I should be harsh, no other way. Plus 329.92 into 7, 329.92 into 7, minus half into 7 into 48, ilva. Half into 7 into 48 is the total load into, from here to here, I would have asked you, but no time, 1/3 of 7 into 1/3 of 7. Please give the answer. First. Answer if you give, over. If you give the answer, I will, now last point is pending, I will finish that one. Answer. Kanta illa. 1936 old answer, fresh answer. This one. Oh, not possible. Do you think I have to lift the calculator? 1917.44. Thank you. 19 plus 1917. Forgot. See, that's how is my memory power. What to do? Except subject, I forget everything. Kilonewton meter. Okay. And lastly, BM at B equal to 0. Okay. Now, or those who want BM at D, look this side. Unnecessary complication. See, fast I will tell. Plus 306.08 into 18, minus 16 into 18, 10 plus half of 8, minus 40 plus 28 divided by 2 in 10 into bracket, 28 plus twice of 40 divided by 28 plus 40 into 10 by 3. Okay, that speed. That's what you call. I am not praising myself. If control is there, that's how you have to tell. If someone asks in an interview, you tell me BM here, look this side. Write it. Little slowly tell me. He should hear. 306.08 into 18. Okay. Minus 16 into 8 into 10 plus 8 by 2. Okay. Minus 40 plus 28 divided by 2 in 10 is the load. Into 28 plus twice of 40 divided by 28 plus 40 into 10 by 3. He will not ask you one more question. He will tell, when are you joining? He will ask you, when are you joining? Why? And how much you are expecting? He will directly go to salary term there. He will not ask you anything. He will tell, he will be knowing that you got the capacity. That's all. Suppose design part, if you don't know, he will be sure this person can be trained and he will be asset to the company. If you tell their bending moment is 60, that way means no. That fluency if you got, by look, you should tell the answer. Now, see, all BMs are over, not over, right here. Every standard point BM over, apart from the standard points, you also have, you are right here, apart from the standard points, to complete the BMD, we also need the BM at that point where shear force is 0. If it is a known point, it is already over here. See, if the SFD crosses baseline at a known point, it is a standard point. It is already over here. If it is an unknown point or located point, yes, it is E. So you require lastly bending moment at E, right? Clearly. You also require bending moment at E. Now you have to look this side. Start. See here, put finger here. Plus, when you want any property here, look here. Okay. Or do one thing, that entry you make here only. Okay, see. Plus 306.08 into 4.7972 plus 8. That is how much? Plus 306.08 into 12.7972 minus UDL. 16 into 8 is the UDL into moment about this point you are taking. Total load here. Sometimes people tell that is a lever arm. Sorry. Lever arm is something else. See, I have seen so many online classes. People tell lever arm. Lever arm is something else. It is for internal force. For when a couple is formed, there you call lever arm. This is called arm. Okay, as long as understanding is correct, such things I will not bother. I won't comment, but I will tell. Don't use the word lever arm, you tell arm. Okay, leave it. Start. Mine into. See, from here, 4.7972 plus another 8 by 2. Lastly, minus moment of this trapezoidal loading about the point E. Moment of this load about here, C here, equal to, see, 40 plus 34.2434 divided by 2 into 4.7972 is the total load. Sum of the two parallel sides divided by 2 into distance between them will give total load into this distance. We want BM here. Into this distance is, from here you want, start, bracket, this side 34.2434 plus twice of 40 divided by 34.2434 plus 40 into 4.7972 divided by 3. This I am not explaining because explained endless number of times. Sorry. Newcomers, learn from there, then come back here. There is a limit. First of all, everything I told so far today, this is the only thing pending yesterday. See how much time I took? Answer. If you give this answer, problem is over. I will draw the BMD and then I will give you alternate solution when X is from here, and then I will explain to you the slope of the BMD. That is how to decide the curve, how is the variation, last point I will explain. Tomorrow I will tell you same this one, if a point load is there here, or if this is more intensity, this is less intensity, or if this is more intensity, less intensity, this all I will tell tomorrow. And also if it is a UVL of this type and here trapezium comes, all the things tomorrow I will explain, full class, only variation. So that tomorrow by end of the class you should be perfect in variation. You should tell anybody, variation, don't talk with me. Why? I am the ultimate expert, not me. You should tell. You should tell, I am the ultimate expert. Oh, you know that much? Yes. You can tell him. You bring anybody and ask me a question. I will answer. Someone will tell, a person called K Shankaranarayana is there. Let him come. No problem. But where you learned? Learned from him only. Answer. That is called confidence. You should tell, learn from him only, but now I am better than him. Okay. Are you sure? 2352.7424. One more person should give the answer because I don't believe one answer. I don't believe one answer. If one more gives the answer, then if one more gives the same answer, yes, I'll conclude. I do not, because it's a YouTube class. After some time, so many will go through this one. They should not find mistake and type comment there that value is wrong. I will tell them, if they tell that value is wrong, means your studying pattern is wrong. If you give weightage to calculation mistake, you are first of all not fit for studying. You find a technical mistake. Calculation mistake, anybody can do it. Okay. 2352 plus 2352.7474. Someone told 7424. Somebody telling 7412. I don't know who is correct. Nandakumar is telling 2352.7424. One more answer is 7412. Which one I should take? See, I give value for 1 paisa also. Now see, someone is telling 7424. One more person is telling 0.7412. Okay. Okay, no problem. Or to save the time, I will round off this to second decimal. Say 2352.74. Then nobody can comment. Why? Because see, it is like in 2,352 rupees. No, one more here. Here. 2,35,000 rupee transaction. Just how much? 1 rupee, 2 rupee difference. Nobody bothers. Okay. So take Nandu's answer. Okay. Nandakumar is perfect always. Okay. 2352.7424. Okay. So Nandakumar answer is taken. Okay. Done. Oh, Nandakumar is recognized everywhere. Take Nanda's answer. 24. But remember, he is not the one. Not that Nandakumar. I think you got confused, I think. He is a new person. He's a new person. Okay. Not that person whom you are knowing. But here he also is serious. I know it. He is not in this group because I am publishing in YouTube. He is using it for gaining knowledge. That is to be appreciated. When an option is there to learn something, you should grab the opportunity. At least you should tell, by attending that class, I learned a lot of things. If he tells that, you will be happy. See, he may not be in the group. See, this will continue only for one more chapter. Then I will continue your batch separately as usual. Entire not possible. At least some information. Okay, now start. Draw BMD. Now, when you draw BMD, be careful. Not blindly draw. BMD, all values are in kilometer and meter, sagging positive. I should sit for some time and mark the ordinate. No other way for me. Why? Because I can't write. I will sit and write. For that one, first I show you the board ones. One minute. I show you the board ones first. 1 minute. Let's see how much space is there. I should know that space problem is not there. See, I can see how much is the lag. I moved other side. There, still I can see me covering. After some time I will come this side. That lag, I don't know why it's happening. Yes, okay. Space problem is not there. Okay, nothing to worry. Oh, actually what happened is, I was seeing the earlier one, I have not moved. See, when you leave the YouTube and come to chat section, then it will stop there. Wherever I saw last time, it will stop there only. Zoom, it will not happen that way. Okay. Okay, now see, I will mark here, I will sit and mark. See the scale. 19C6, 1914 and 2352. First I will mark this 2352 here. See, here. No, not there. See, this is the point where it is highest value bending moment. How much? 2352.74. It is, this ordinate is 2352.74. 7424. Nandakumar answer. Okay. Now, that is the point E. Red color point. See, that is the red color point E. Now, I will bend, sit down and write. C, I will first project it. C, I will project here. D I will project here. Okay, now start. 1936.64. 2300, 1500, 1150. 19 means further 2, 3, 400. 424. If I divide into 6 parts here, it will come in the 5th part. Okay, reasonably okay. Now I can't do anything. 1936.64. Okay, reasonably okay. I will change later if requirement is there. Here it is, point is 1917.44, slightly lesser. Come here. Correct point? E point. ಸ್ವಲ್ಪ ಕಮ್ಮಿ. Okay. 19, little out of scale. Okay. 1917.44. Somewhat reasonably okay. Slope will shear force common. Okay. Now, before I stand up, I want to confirm. Okay, done. Now I will tell the principle for you, for joining. See, the joining principle very important. Remember, one comment I require from your side. Last comment I want. See, you should write one more thing here. Variation of BM, right? You write here. A to C is parabola of 2nd degree. C to D is parabola of 3rd degree. D to B is parabola of 3rd degree. Make a note. UDL, 2nd degree parabola, quadratic. C to D and D to B, you should write it. Variation, 2nd degree parabola for AC, 3rd degree parabola for CD and DB. When you discuss the variation, you should not talk about the point E. Remember, point E will not come for variation. ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಸ್ಕೇಲ್ ತಪ್ಪೋಯ್ತು, ಇದು ಇಲ್ಲಿ ಬರುತ್ತೆ ನೋಡಿ, ಇದು ಪ್ರೊಜೆಕ್ಟ್ ಮಾಡ್ತಾ ನೋಡಿ, ದ್ಯಾಟ್ ಇಸ್ ದ ರೀಸನ್. 7 minutes ನೋಡಿ, ಇದು BMD. Okay. You should not discuss the point E. Variation is, see the loading, A to C, C to D, D to B, but it has to pass through E. Okay, start. Now, all parabola, 2nd degree, 3rd degree, parabola means some change will be there. That all graph sheet we don't have. Then you have to do one thing. You have to get another intermediate point solved. That is not required. Draw the shape correctly and fit the curve properly. See, I will join here by a 2nd degree parabola. Okay, now tell me what is the slope here? Slope here is shear force here. How much? 306.08. The slope is like this. When they cross this point, the slope, shear force is negative. Instead of this way slope, it should come this way slope. But it will come. Okay, now here, ಸರಿಯಾಗಿಲ್ಲ, ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಬೇಕು. ಸಿ, I can make out here. Okay, now see. Okay, now okay. Okay, this way. Now, slope here is 3.0. Here, tell me, if I draw a tangent to this BMD here, what should be the slope there? Okay, no time for chatting. Slope of the BMD at C is, don't see intensity. To decide slope, see shear force. This side is 178, bending shear force. Even that side also 178. So, the slope of the parabola at C for CA and also for CD, both of them should have same slope. Why? Ending shear force is 178. That is the slope for end of the curve. Starting shear force is 178. That is the slope of the continuation curve. But if a point load is there, then shear force will be different. Tomorrow I will tell it. If a point load is here, then shear force diagram, 2 values will be there. This side shear force is a slope for the ending of the curve, and that side shear force is a slope for the next continuation of the curve. Tomorrow I will explain. So now, from here, this is 2nd degree parabola. 2nd degree parabola. Again parabola of 3rd degree. But one thing, even that should have, it will reach a peak value here. Peak value and drop back here. Now, if I draw tangent to that also here, Okay, now see, in this, ayo, asariyagiಲ್ಲ ಇರಿ I adjust it. Now see, okay. Now, if I draw tangent here, for both of them, tangent should be common. See, ending part, what slope comes? Same slope should come to the starting. But then onwards, shape will change. Okay, this is parabola of 30 degree from here to here, highest value here, where here shear force is 0. So if you draw a tangent here, the slope should be 0 here. Here slope should be 0. I remove that one. See, by marking tangent here, you can make out slope is 0. Okay, now, when you come to the end point of D here, the slope of this line, tangent here, should be shear force here for this side, 161. Shear force for that side also is 161. So, this parabola, second degree parabola should come this way. So that here the tangent will be common for both. That is because end of the parabola slope and starting of next parabola, this is third degree, that second degree, the common tangent, slope same. And here slope is high slope, why? Shear force is 329.92. These all I explained earlier. So if anybody got newcomers, those who are regularly coming, I don't have to tell them. You will, by this time you will think, how many times he is selling same thing? What to do? Teacher's instinct. So, plus, irli papa, plus. ನಾನು ಪ್ಲಸ್ ಐನೇ ಹಾಕಿ ನಾನು ಬೇಜಾರು ಮಾಡ್ಕೊಳತ್ತೆ. ಸಾರಿ, ಕನ್ನಡ I can't speak here because, okay, no problem. My wish. Now, this will complete the question. Tell me, fully clear or not? Now I will do one thing. Today only I will tell you, instead of x from here, if you take there, what will happen? Today only I will explain and conclude. Then, tomorrow I will tell you, if a point load is here, not there, or if a point load is here, not here, or if both the places are there, how the slope will change, what will happen to shear force changes. I will explain everything tomorrow, so that by end of tomorrow class, you should tell in future how is the curve for SFD parabola comes, and how is the curve for BMD when a parabola of second degree or third degree comes. You should tell, I am is not me. You should tell that I am the ultimate. Nobody can beat me. Somebody can be equal. Someone tell my name. He will be equal to me. He can't beat me. Why? Because whatever he told, I learnt it. Now I am equal to him exactly in the knowledge for these things. You should have that confidence. Hope you will get it. If you tell you can beat me also, no problem. Beat me. Not by hand actually. Beat means not by hand. By technical beating. Okay, now, you are not told everything clear or not. If you tell everything clear, I will go to the next part. So today's class actually maximum repetition. Even someone missed last class. See, now one who missed last class because of some problem, you watch in the YouTube now, in mobile you can watch. I think everything will be clear now. Okay, now, lastly make a note. See, everything over. These all I am not removing. See, now make a note. 34 point, I make a note here. I lay the 34. 34. Where I wrote? I write here. 34.2434. Okay. Now make a small note. See. Make a note only here. Note. Gamani see. When we want to locate this point E, we took x from here. Then that intensity you got from 40, we found out how much is the decrease. See, in this equation, if you put x equal to 0, you will get 40. If you put x equal to 10, you will get 28. That is a check for you. Okay, now suppose, yadi ಒಂದು ವೇಳೆ, suppose we consider E at x from D. See, you require it because sometimes what happens is, in cantilever solve, you have to usually take from the free end. So learn the procedure, x from D. Then what happens? See, what happens? BM at A, BM at C, BM at D, BM at B will remain same. Why? BM at A 0, BM at C, look this side, BM at D, look that side, BM at B remains same. So I will remove everything now. these all will not change, but the value of x will change. See, you take x from here. Nothing to worry. Means here, see, x is from, not here. I'll remove this x now. Okay, I'll put here x from here. See, if it is 4.7972, this I'll remove now, not required for us, then that value has to come 5.2028 meter. It has to come. Okay, now see, what to do is, then your intensity W at E will be equal to x from here. Now you should start from here. 28 plus 40 minus 28 is the difference. Divide by 10 will give the slope of that line. See, again mathematics. That is the rate of change into x will give it. If not clear, study the class of mathematical concept, class number 3, again and again till you get perfection. Now it will come 28 plus 1.2 times x. Okay, therefore come back here, change it. 28 is not red color. 28 is black color only. 28 plus 1.2 x. Now do one thing. This has to come. I will tell it. You stay there. Now also you are only coming. Okay, now 1 minute. Still we don't know it. Remove it. Now in this equation, x from here, put x equal to 0, you should get 28. Put x equal to 10, you will get 40. Last time not that way. When you put x equal to 0, you got 40. When you put x equal to 10, you got 28. Now since x is from here, put x equal to 0, it is 28. Check it. Put x equal to 10, it will come 40. Okay, now look at this is over. Now shear force at E equal to, you want shear force here, look this side. Here also, not that side. See, at E here, look this side. Okay, start. When you look right side sign is left up positive, right down positive. Sorry, I should not have told it. Right down is positive. So, minus 329.92 plus this triangle load half into 7 into 48, actually not required. That much answer is minus 161.92. Okay, early. Again minus plus this much load. That much load means this much load. How much it is? Plus how much? 28 plus 1.2x plus 28 divided by 2 multiplied by x. I am not explaining area of the trapezium equal to 0. You will get 28 plus 28 is 41. 1.2x into x is 1.8. You get 0.6x square. When you simplify, you will get then 28 plus 28 is something divided by 28 only. Plus 28 times x minus undoubtedly 161.92 equal to 0. Solve the equation, 2 values of x will come. Solve the equation, 2 value of x will come. X has to be more than 0, less than 10. Between 0 and 10, only one value will come. If between 0 and 10, if 2 value comes, I will not continue teaching. Okay, start. Tell me the x value which is in the range of 0 to 10. Tell the answer first. Tell the answer. Those who got confidence in me, they will not calculate. You calculate. Those people who got confidence in the class, they will not calculate. Tell the answer. But you calculate. First. Last answer I am asking you. Answer. First. Hope. Any problem? No technical problem, I think. There seems to be. Oh, no problem. I'll switch off the charging. It is showing overheating. I'll switch off the charging. Okay. Charging It's creating overheating. Okay, now charge is sufficient. Okay, answer is 5 point, your answer 5 point Kempalle Pariyona. It is, I am not seeing there. Your answer 5.202803601 is the answer. I told you earlier, same answer has to come. Otherwise, from after today, I told no more classes from my side. It came. Maybe it thought, if I give wrong answer, he will stop teaching. Better, at least he is doing something. Let him continue. So it has pity on me and gave same answer. Okay, leave it. Now, but we will take, how much? We will take 5.2028 meter. Go back and enter 5.2028 meter. Enter there and also enter here. Already entered. Oh, this is anticipatory bail. See, if you feel that there is a chance of arrest, you go to court and get anticipatory bail that way. Anticipatory, we put the answer. That is confidence only. Okay, lastly now. Substitute this X and get intensity W at E. You substitute 28 plus 1.2 into substitute X, 100%, it will come 34.2434 kilonewton per meter. Enter here. Yes, tallying. See, I did not calculate. Now, lastly, over. Last for this class is BM at A, BM at C, BM at D, BM at B, no change. The last part of today is BM at E. Okay, start. Lastly, everything same. So BM at E, this time little change. Why change? Okay, change because look this side. Start. 329.92 into 7 plus another 5.2028. So it is plus 329.92 into 7 12.2028 minus half into 7 into 48. Half into 7 into 48 is the load into about this point 5.2028 plus 1/3 of 7, not explaining because you are expert here. Lastly, minus moment of this much load about the point E. This one, that one you see here. See, first total load is somewhere here. How much load? 34.2434 plus 28 divided by 2 multiplied by 5.2028 is the total load into from here to here this distance, that is A plus 2 formula from here into 34.2434 plus twice of 28 divided by 34.2434 plus 28 into distance between them is 5.2028 divided by 3. A plus 2B by A plus B into H by 3. Not explaining, calculate. You just comment clear or not, sufficient. Calculation I will do it. You just comment clear or not, sufficient. You just tell me clear or not. Calculation I will do very fast. I got a super calculator with me where you show it to the screen, it will calculate. I have got it there. I usually never use it. Emergency, when time is not there, I use my super calculator. You tell me clear or not. You tell me clear, sufficient for me. If you tell clear, I will calculate. Don't calculate. Just tell me clear or not. Right, no comment, see. I just want to listen, see that word, clear. Okay, thank you. I will use a super calculator. It is hidden inside. It is a super calculator where, see, modern one. If you want, this is for sale. Cost I will tell you later. You can bid your cost. See, all you have to do is open it and screen it. See, swipe it here. answer comes. 2352.7424. 23, light is not proper. 2352 plus 52 point, light not proper. 7424. Okay, now check the answer. Oh, see here. Exactly same answer. Super calculator stops. Now I will use it only for emergency. Very expensive one. See, very expensive one. Okay. I will put it in the safest place. Yes. Therefore, we got same answer. Now draw the BMD. BMD will not change. But now X is from this side. Complete clear means tomorrow I will tell you more information for this question. I will imagine a point load here. Then some change are coming here, some change are coming here. I will imagine a point load here. Then this will not change. Some change will come here, some change will come. I will put a point load both the places. Both will change. And I will put a point load here and I will tell you SFD crosses baseline under that point load. Then some change will come here. It will not be zero slope there. Like shear force will not be zero there. Actually zero is there. I told class number 100. Special, what that is called high level of knowledge. Okay, that all. Tomorrow I will explain so that once tomorrow's class is over, when I go to couple or what, overhanging beam or cantilever, there you should not ask me, sir, why curve is this way, why curve is this way. Then I will tell what you did on that class. Class number today is 98, correct? 1 minute. Yes, I will remember always. Class number 99 for you. Century previous class. 99 for this group. Whereas in YouTube, that special is class 100. I will always remember now. Class number unlucky 99. Unlucky 99, you make it lucky 99. You are still batting. 99 is unlucky if you get out. If you are still batting, 99 is good. Okay. So tomorrow I will continue. Attend the class. Learn lot of concept tomorrow. I will not do any problem tomorrow. I will explain so all this concept here. I will take that, but at that time, reactions, I will randomly put it. Okay. Thank you. See you tomorrow then. Maybe after around 1 hour, YouTube will process the video and make it available. I don't know. Yesterday it was processing up to midnight also. But when I clicked the link, it was coming. Anyway, it will come now. Maybe usually 1.5 hours it will take to process and upload. Right now it is there. I cannot see because I am the host. When I touch that one, for me it plays always. It will tell, you are the host, no, you see whenever you want. But others, you have to wait till uploaded. 1 hour it will take. Okay, thank you.